G'day everybody and welcome back to my channel. I just did a little bit of work on this, took a video of it, and then I'll just show you quickly what I did. I'm a dumbass. I compared the output of this comparator and the base drive of this FET and this transistor and this transistor's voltages against all of this, only to realize I'm a dumbass. This and this is the same side. This and this is the opposite polarity side. So I then remeasured everything again against this and found out that yes, there are a massive difference between the output of the comparator on the positive half to the negative half. So our problem is actually behind the comparator. So that being said, I'll now continue on with the rest of the video. G'day everybody and welcome back to my channel. I just did a little bit of work on this, took a video of it, and then I'll just show you quickly what I did. I'm a dumbass. I compared the output of this comparator and the base drive of this FET and this transistor and this transistor's voltages against all of this, only to realize I'm a dumbass. This and this is the same side. This and this is the opposite polarity side. So I then remeasured everything again against this and found out that yes, there are a massive difference between the output of the comparator on the positive half to the negative half. So our problem is actually behind the comparator. So that being said, I'll now continue on with the rest of the video. G'day everybody and welcome back to my channel. I just did a little bit of work on this, took a video of it, and then I'll just show you quickly what I did. I'm a dumbass. I compared the output of this comparator and the base drive of this FET and this transistor and this transistor's voltages against all of this, only to realize I'm a dumbass. This and this is the same side. This and this is the opposite polarity side. So I then remeasured everything again against this and found out that yes, there are a massive difference between the output of the comparator on the positive half to the negative half. So our problem is actually behind the comparator. So that being said, I'll now continue on with the rest of the video. Alright, so it's the next day again. I haven't had as much time as I've planned on having the last few days. And I'm back on this. Now I've actually done a few things. I removed R253 and 258 to try and turn off the FETs. That doesn't turn them off, they just stay turned on, so I put them back. I then removed Q151. I'll show you in the schematic where that is. And after doing that, now I don't have the leakage voltage, because this was the path of the leakage. So I've taken that out, and now I've got normal rail voltages. I'll just demonstrate that. So that's your 40, 80, 40. Alright, so I don't have 63 volts roughly on a 40 volt rail anymore. I've done that so that I can take measurements without the rail voltages being uneven, causing all of my measurements to be uneven. Now, the other thing I noticed was Q132 and Q134, the pins were so corroded, I actually took them off. Well, I tried to reflow them first.
As I did that, the solder like peeled away from the pins even worse. It would not take to the pins. I had to take them off the board, clean the pins up with a Stanley blade, like just an individual blade like this, and then I was able to, tin them up and reflow them. Nothing else seems that badly corroded. There's a capacitor there and one here. This one's a little bit more worse than that one. It's a little bit dulled and corroded looking on the outside of the solder, but it doesn't actually look like the joint's like going dry or the solder's not sticking to the end of the capacitor. But those two transistors, they almost like, it looks that bad after I tried to touch it up that I would have said that it was out of circuit almost, Anyway, so I cleaned that up. Like I said, removed Q151, so I've got even rail voltage. Now, I'm up to trying to work out why I've got no, you want to call it bias, base drive, why it's not there. I have also incidentally removed Q124 and Q122, which, just so everyone knows, it's these two guys here. So I've isolated the amplifier from the input section. Well, it's still got the negative feedback path here, and there's still a feedback path here for the max power adjust, but that runs off plus minus 15. I don't think that's causing the problem. Who knows? We'll see. But at least now I can take some actual measurements. So that's what I'm going to do now. I'm going to power it up with those removed, that removed, so we've got even rail voltage and the whole, the VAS where the VB multiplier is the bias area, and the Darlington output is all isolated. I want to have a look and see just basically what's going on. So as I would expect, there's nothing on the base there. Oh, hold on. Okay. No, that's okay. This board is so convoluted and hard to stare at. They just seem like floating bases to me. Okay. Maybe it is further back. Okay, I'm just going to pause the video and have a look at the idling adjustment section, as it's called on the schematic. See what I can work out there. I've got a funny feeling the problem's either coming from there or... Actually, let's see what's coming out of here. Because this diff pair here is... yeah, it's mirrored off of another diff pair. That's how they've coupled the low voltage side to the high voltage side. It's DC coupled, but that's how they've done it. So it's these two. Wait, no, it's not. That's the emitters. No, it's not. This board is so hard to work out. Wait, what? There's no transistor there. Oh, the V goes off somewhere else, doesn't it? There shouldn't be. I need to have a look at the manual, work out what pins are what, like emitter base collector for these transistors, and have a look at this section. Something seems a little bit off here. I'll just leave the video here and do a bit of studying and I'll come back.
Okay, so the whole having high voltage, my mistake, on both of these makes sense, because if we go up here, one side just goes straight through a 120 ohm resistor and a diode straight down, so that explains that, and the other side goes through this. So what I'm doing now, I'm taking some open circuit measurements here, like making sure voltage is present outside this diode, making sure this transistor is functioning the way it should be according to how it's biased, blah blah blah. Then I'm going to put them back in and do some more testing, because obviously for current to flow through the whole chain they need to be in there. But before I put them back in there, what I am going to do is I'm just going to do a quick check over these transistors, just in case there's any I missed, because I got a funny feeling that I didn't test these TO92 transistors and I might have missed a couple of small ones around there, so I'm just going to check them. But I'm starting to really lean towards this being a transistor leakage problem. So what I mean by that is transistors passing a small amount of current, but you can't see it with the multimeter, because when you bias it on, the junction turns on more than the little bit of leakage current, so you just don't see it really. You know, it might present a slightly lower forward voltage, but you know, it might only be a few millivolts and it's not noticeable. The other thing is too, with transistor leakage is it's hard to explain. It can present itself in funny ways. Let's just leave it at that. Sometimes it can only happen at certain voltages, at certain current thresholds, certain criteria, maybe when it's only cold, maybe when it's warm, maybe when it's hot. All sorts of funny things can happen with transistors like that, and I'm starting to lean towards this being a leakage problem, because the first thing I did when I took this thing out was tested all the outputs, as you do with an amp. Started the output, because that's usually what gets cooked, and everything tested good, and I moved my way back and I tested all transistors in it basically, and everything tested good. Now, the only other thing that could be masking that is base to emitter resistors. So there could be a base to emitter junction on a transistor that's shorted or at least leaking, but because there's, say, a 33 ohm resistor from base to emitter or whatever, you can't see it with the multimeter. So that's the other thing that could be hindering me here. So what I'm trying to say is that the problem could be actually still in the output, and I've just missed it the whole time. The thing is, I didn't want to just go and desolder all the output devices and individually check them, but well, that's what I'm going to do now. Is I'm going to
test out the circuitry that I've just showed on the screen, the idle adjustment, VB multiplier, the what do you want to call it, the current source and sink that sort of buffers the diff pair signal, all that stuff. I want to test that and make sure it checks out with, you know, how I believe it should be functioning, which is pretty easy to work out. I mean, it's annoying that there's no voltage. Voltage is written on these modern day schematics, but it's an amplifier, and it's pretty simple how they work. So I can sort of just look at the schematic, you know, and I can do a little bit of basic math and I can work out what should be present at what points. So I'm just going to do that in this little area, the VAS and the idle adjustment area, and then I'll come back with my findings.
Alright, so there should be voltage here the other side of this diode, but there should be no voltage here at the moment with everything, the two transistors down there, removed. So let's verify that.
At least we're getting somewhere now. Q118's here. That's the resistor that goes to its emitter. That's the diode that goes to the base. So this is the collector. Yeah, there's nothing on there. That's what I would imagine a floating transistor to look like. Alright.
I'm going to measure, actually no, I've already measured, there's voltage present there, so I know that resistor's not open. Okay, so I'm going to put these two guys back in. Actually, before I do, let me just see if there's any voltage present on in between Q122 and Q121.
Because if there isn't, hold on a sec. Q122, Q121. Where are you? Q121. Okay, so the entire output stage actually doesn't have any drive going to it with these out at the moment, which is a good thing. Pretty sure I already checked the bases, but let's just look one more time. Nothing floating. Oof. That was bloody close. Wow. I just turned that on for a second. Charged something up and it's coming back down. I guess it's only one side, so it's not like it was going to smoke the output stage by turning both sides on, but still. That's why I like these caps, because you can still do it, but you know. Anyway, yeah, okay, I'm happy with that. Yeah. Alright. What did I say? Q121 and Q122. There was no voltage present there. Okay. Let's put these two back in. I know this might be a little bit annoying, taking things in and out and all that, but I had to isolate the stages. It was just confusing me too much with the rail voltage being off, with Q151 in there, and the whole input stage, output stage links together. It was just baffling in my head. It's a lot easier now for me to sort of just trace it out from the start. in my mind anyway. Each to their own. I won't lie, I also haven't, man, I haven't been doing too much electronics. I've only just been getting back into it the last few years, and the last time I was working on amplifiers, like repairing massive faults and building them and all that sort of stuff, was a few years ago, when I just started getting back into electronics basically. So I got to get used to it again. But I'm the sort of person that whilst I might forget something, I'm a really fast learner. So, I'll have to work on, say a Darlington amplifier, a quasi complementary amplifier, a few different input stage arrangements, and I'll pick it all straight back up again. It will just flash back to me, and I'll be all right. It wasn't that long ago. I know you can just like dab it all over it, and because it has flux in it, and you've got the solder mask, it'll sort of just find its way to where it needs to go. But I've done that a couple of times and it's made a mess of it. I'm just going to try it just for these two, just to experiment, because that's something I was going to ask in this video, because I'm going to have to teach myself some techniques for SMD. I know how to use a stencil, but I mean, when you're trying to use solder paste just to put a couple of components back on, I was going to scrape it out and dab it on to each pin, but I just want to see how well this paste flows when the whole area is just covered. So let's see. God, these pins are oxidized as well. What? Now that I look closely, actually a few of the transistors have oxidized pins. It's not on the bottom, but the top is. I can't in good faith leave them like that, because I know that in some time, maybe a year or 2 years, those dry joints will become open or high resistance, and the amp will be back somewhere for repairs. I can't remember if I scraped the outside pins on this. Alright, that's in between back to solder and copper, so that will work. I know my head's still popping in the way. I'm going to rearrange it and do it. Obviously, this is better set up like this, but I know every so often my head is in the way. I've had a look in between clips. It's alright, I'll rearrange my setup a little bit more. We'll get there. We'll get there. That's my door. Give me 1 minute. God, my luck. I literally just go to start reflowing that, and that happens. Ah! My pinky. Oh, shit, I'm gonna have to go. I have to redo them. I think I just burnt my hand. No. I think it's alright. Oh, God, this ain't working for me. Oh, I got them. It's all good. Oh, mate. Tell ya. My pinky touched the hot end on that, and ow. That's all I'm going to say. Oh yeah, no, they actually flowed in. Okay, I'm happy with that. The pins just looked corroded, like the other two that I had to clean up. I'll just wait for them to cool down before I clean that area up. Well, I did burn my finger a little bit. I can't see it, but it's stinging a little bit. At least I don't have to go and stick it in water. It's not that bad. The aluminium heatsink feels nice. I just want to clean it up so I can make sure that there's no solder balls in between the legs causing a short. I can't see. Jeez, my finger is starting to sting. I might have to go stick it in water for like 15 minutes. This bloody spray bottle. Beautiful. Alright. With that out of the way, yeah, my finger's starting to blister. I'm going to have to go put my finger in water. I'll be back. Alright, I've come up with a 2-in-1 solution. A cold can of coconut water because I get to drink it, and every time my finger stings I can just touch it. Cool. Now I can keep working. Nothing I hate more than having to sit there with my hand on something cold. It's a really, really, really mild burn, so I'll get away with this. Alright, so looking at the schematic, the VBA multiplier transistor, the one that's in between Q129? Sorry, no, Q118. This one. The one that's in between that and this diff pair down here that's got the adjustable pot. That is Q121. Oh, I'm a dumbass. I've already checked that, haven't I? No, I checked that without those in. So they're in now. Okay, so now... Okay, now I'm actually going to start back at... Sorry, my bad. Burning my finger just totally jogged my memory. It took my memory from where I was up to. Q118, I want to see what that's doing now. That those are fitted. It's interesting. What's on its base? Okay. Fair enough.
So that's doing its thing. Q121 should now have, well, there should be a voltage on its output, and when we adjust VR104, the voltage on the emitter should change. Also, the voltage on the collector should change, but I'm more interested on the emitter side.
So Q121 is that. I just need to work out what's the emitter.
Okay.
What value is that? Cat. Sorry. Sorry about my head. $100. Oh, right. That is the cap that I want to look across. So
The positive side is obviously the collector, and
yeah, the negative side's on the emitter. Okay, cool.
Right. That doesn't make sense. I would think there should be a bias voltage present
There. Let's look across that cap. No. That's the cap across the VB multiplier's output. And there is nothing there.
Okay. Moving down, Q122 is what its emitter goes into the collector of Q122,
Which is this guy.
So
What's on the base of Q122? And which pin is the base? So we've got a
120 ohm emitter resistor.
so those two pins are the emitters. Or I'd say the tabs would be the collectors, and these must be the bases. So Q122's base, has nothing on it. Well, if Q122's turned off, current can't flow through the bias network, and there can't be any idle current. Now, Q122 goes back to the other diff pair that's powered from the 15 volt area. Okay, bloody hell, I'm going to have to put the 15 volts back on. This is a good one, isn't it? I might end up having to make this a two-part video. Well, I mean, a couple more parts on top of the first couple of parts. But let's face it, the first few parts we just sort of looked at what's wrong with it, and you know, are the outputs shorted, that sort of stuff, you know. Oh god, just buggered all of those up. Worst comes to the worst, I can re-terminate this cable, it's not a problem, but let's try not to have to go to that extent. Let's see. Bloody finger. That's much better. Alright, now, first things first, let's have a look and see if that's restored the bias. I don't think it's going to somehow, because I never had bias in the first place. Yeah, no. this is a head scratcher. This is just too much of a head scratcher, this one. Okay, so Q122, I'll show you guys the schematic because we haven't really looked at this section together yet, so where's my mouse? Let's use my finger. That's Q122, the one that needs to be turned on for current to flow down here. Q124 was turned on, I'm pretty sure. Yes, we had voltage on both sides of it and the base. So Q124 was turned on. Let's have a look at Q161 and see what's going on there. Do I need the 15 volts for that? One moment, sorry. No, that's still running off of the 70 volt rails. Oh, I just realised, I think when I looked at this before, I said everything from here forwards is low voltage. No, actually, the end of the high voltage rail is there and there. It goes back to there. And this line goes back to the input of a comparator. Okay. Alright, let's have a look at Q161. I think I'm just going to leave this cable in for now, because the area of circuit that I'm getting into is powered from the plus minus 15, so I'm not going to get any usable readings without it being powered. God, my fingers don't actually sting now, to the point that it's annoying me, and there's a white blister coming up. So Q161 is here. Again, I need to work out what's what pin. Well, its base is connected to the emitter of Q114, and I can see a track connecting those two pins together, so that must be the... Oh no, these two pins are connected together as well. Hold on. Where's the capacitor? 330 picofarad? Yes. Okay, 330 picofarads on the emitter of Q161. I already know that there's nothing there. I don't think there is. Oh. Hold up, we might have just found our problem. Q161, its emitter drives the base of Q122. Q122's I think it was here we were supposed to be looking at. Oh, what? Yeah, that's still definitely not right. So it's different with the input stage powered up. No heat being generated. Hey, how can that be the same on both sides? Something's wrong in this section. Sorry, I'm just getting a bit lost with the schematic. Might have to stop and have another stare at it, study this section now. Still no bias. Oh, my finger's starting to really sting. I'm gonna have to pause the video. My apologies. Alright, I think it's like day 3 or day 4 on this. I haven't had too much time the last few days, but it's 8:45 PM and I've got some spare time. I know it's not a lot because it's late, but I think tomorrow actually will have some time, so hopefully I'll be able to get most of this sorted tonight and get something else done tomorrow. Anyway, I've moved the camera back a little bit further again because I noticed my head's still in the way. And I think what I'm going to do also is just try and move the board towards me when I need to see sort of behind something instead of doing this. Anyway, where I want to pick up from now, I left some notes for myself last night on a piece of paper. The things that are of interest to me. Why is there 6.2 volts on one diff pair and 80 something volts on the other diff pair? Why do we have no bias? Why do we have the same voltage on each side of the bias cap, which I think was 6.7 volts or something? The mute circuit, I know I had a quick look at it, but I want to have a better look at it. Because, see, here's the thing, a lot of these signals, like mute and that, they go back to the power supply board, which has transistors on it that switch in and out certain signals, which enable the amplifier. The mute signal, for example, might disable the input stage and unbiased amplifier, you know, essentially turning it off. So it might be the mute circuit that's causing a problem, you know. Given the fact that the rail voltage is being forced to switch high and there's that leakage problem and no bias and all the weird symptoms there are, I don't think it is that. I think it's something else, but it's still something to bear in mind. I'm just going to shut the door because one of my cats is on heat, and I also noticed that was very noisy in the last video, and I'm honestly trying to get better at my content. Alright, that'll keep out outside noise. My neighbours are all, my neighbour, he had a car accident, his arm's broken, so everyone's coming over to visit him at the moment, and that's quite noisy too. Anyway, yeah, so that's basically it. Why the strange voltages on the diff pair, why no bias, why the same voltage on each side of the bias cap. Is it a mute circuit problem? Is it a power board issue? So the way I'm going to go about this, I'm just going to take you guys over to the schematic, is I know I already started having a look at voltages and stuff here, and I'm sure this transistor, that diode, all that's doing what it's supposed to be doing.
I haven't had a look at this transistor yet. I think it's okay, but it, you know, given that it's creating a feedback path for the max power adjust, it could have something to do with it. I don't think so. Other thing I have to point out is this diff pair here, this transistor, by the way, is the mute. This goes to the mute line. So when this is open, no currents flowing. This is all off. No bias currents flowing into here. This is all off. Output stage is off, right? So that's how the mute works. This diff pair here, I forgot what I was going to say. I need to work out how it works, because this bottom rail here, not this one with the 2.2k, 2.2k, that's the end of the minus 85 volt rail, and the positive end of it ends here. So you see the difference, right? So this diff pair is in between the minus 85 volt rail and the plus 15 volt rail. This goes back to the plus 15. That's why I've made it a little bit smaller, just so that I can show you guys exactly where power's coming from. That way, when I go and take my meter and say hook it up to the plus 15 volt rail to measure like this point here and this point here in reference to that, you guys understand what I'm talking about. Because at the moment, everything I've been measuring has been referenced to ground, because we've been in this section and everything's referenced to ground. Now we're getting back here, we're getting tied into the plus minus 15 volt rail, which is tied in with some of the high voltage rail and inherently the other rails due to feedback paths and stuff like that. So it's going to get a little bit more complicated. So I just wanted to cover that so no one's lost on what's going on. Because of that, what I'm going to do is I'm going to find a convenient location for the plus 15 volt rail, and I think I'm just going to mount a little wire or something like this on it so I can clip onto it. Because now that we're back at this back part of the circuit, I'm basically going to be wanting to look on the minus 85 volt rail and the plus 15 volt rail, because all that circuitry is between those two rails. So if I want to see, I don't really need to explain this anymore, you guys get what I'm saying. So the 15 volt rails, this end wire, it's red on the other side. Nice and easy. There's a spot right here, a capacitor. So I'm just gonna tack a wire onto that. I use an insulated wire because it's owns the board. I don't want it to touch anything. I'll just pause the video and get a thicker bit of wire than what I've got up here. This is why I keep this box of scrap wire. I've got an interesting wire collection, but I'm never short, so it's always good. That'll do the trick nicely. I just dropped the lid. Everything I drop in here always takes too long to find. Like, you never understand it. Oh no. No, they haven't. No. You know what I just found on the floor? This is what happens when your cats get in the lab. Yeah. Someone's been having fun. Oh, you know what? No, I don't think it's the cats. These are all about to come off. Okay. Usually when my wires get broken in here, it's the cats. A good example of that, I've actually kept some of these. I don't know why, I should toss them in the bin. I think I'll do that now actually, after I've shown you guys, but this is just hilarious. I mean,
at the point in time when it happens, it's not hilarious because I've just breadboarded like 2 breadboards, 4 ICs and complicated circuitry and stuff, and then they rip the wires out. And not only they rip the wires out, but they do this to the wires. Like they chew them. Yeah. So that ruins my day a bit. Especially when I haven't drawn a schematic for what I'm doing and it's something I've actually designed. It's not, you know, like an already existing product or a really standard circuit, you know what I mean? That you just, you know what I'm saying? It's something that's niche. You've just designed it, and then before you've drawn a schematic for it, the cats come in and rip it apart. That's happened too many times. I try and keep them out of the lab now for that reason, and because they've pissed on things, and that's created great grief. I've lost a crap ton of high quality like coax and all sorts of stuff like that because the cat's pee is very, very corrosive, and what it does is it wicks up the cable, and I mean wicks up it. It actually surprises me. I mean one small drop, and I mean literally when I say like I'm not exaggerating this. I'm telling you, you get one drop the size of like, okay, one of those, one drop, okay? You get one drop on the end of the cable, and the cable can be like 1 meter, 2 meters long, and a couple months later you come back to the cable, discover that there's a drop of cat piss on one end of it. You go to strip it, it's all oxidized and black. You cut back, say that much, it's still black. You cut another bit off, it's still black. You end up with a whole pile of offcuts this long and no cable left. The whole thing's gone. That's happened a few times. So yeah, due to that and the eating of cables, I try and keep them out of the lab now. But the problem is, because I've got limited time, my work's on call, and you know, I have a busy life on top of that already. Well, because of that, it's like some days, you know, when I have the time, I can come in here and just be working in here for hours in one go, you know, and then I'll leave and shut the door. Other days I don't have so much time. Well, on those days I've got a bad habit of walking in, doing something for, you know, 5-10 minutes, and then walking back out again. And I'll leave the door open, and then the cat's coming. You see my problem. Anyway, enough about the cats. So, let me just pause the video whilst I get my thoughts together and think of what I want to look at first, so I don't waste everyone's time. Alright, first place I'm going to look at is R281. R281 is on the collector of the mute transistor. So if there's voltage present, and it's going to be a low voltage, like, well, there's a 3.3k resistor going into the mute transistor, a 6.8k after that, and then it goes into a long tail pair. So whatever current the long tail pairs sinking plus the voltage dropped across those resistors is the voltage that's going to be at that point that I measure. So it's not going to be a huge voltage. You know what, I'm just going to do a rough calculation just so I've got a ballpark figure. One sec. Actually, I can't do that until I know what voltage is in between the 15 volt and the what is it? Well, I'm pretty sure it's a minus 85, but I just want to double check. Yeah, minus. Well, it's the white connector. I think I'm going to have to check myself. It doesn't say on the schematic exactly what it is. It just says the white connector when I trace it back. So, God, I've forgotten what transistor it was. Here it is, Q110 R281. Alright, so what's the minus 85 volt rail? Yeah, white. Okay, so what is my voltage between plus 15 and minus 85. Okay, so there's 108 point, call it 108.5. Maybe even 110 by the time it fully warms up, because I've noticed the rails do come up slow on this. I think it's, yeah, it could be a power supply issue on here, but I don't think it is. We'll just call it 110 because it's probably going to get there and it makes the math easier. Alright, so now I know I've got 110 volts across that pair of transistors and resistors. I can do some basic maths and work out the volt drop and rough voltages that we should expect. Give me one moment. I just wanted to point something out. I don't know if anyone notices every time I turn this on. Let me just turn it off. I turn it on, you see this flash? That is the dim bulb. It's not running through a dim bulb because it's going to stop it from getting smoked. Let me make this perfectly clear. There's enough power in those capacitor banks with the switch mode power supply running that if something goes ape shit with 100 watts of bulb in series with it, it's not going to do nothing. The output's still going to get smoked. It won't have enough power to completely go up in smoke and crack transistors, but they will still fail short inside and it'll all be toast. The reason it's on the dim bulb sorry about that. I keep thinking someone's at my door. It's my neighbours. It's been doing my head in for like a week now. Anyway, I guess he has a lot of friends. Anyway, as I was saying, the reason it's on the dim bulb is because if one of the transistors or something on here starts to consume current and go into runaway, I will notice those starting to glow more, and I'll know to turn it off quickly. So although it won't protect it from a sudden short or a sudden turn on of both sides at the same time, if something starts to conduct, I will see it. And then I'll be able to turn it off before absolute destruction occurs. I just wanted to point that out. Alright, first thing I'm going to do is look at R281 in reference to the 15 volt rail, and I'm going to look at the mute line in reference to the 15 volt rail. Look at the mute line first. Okay, that's got 15 volts on it. That's a good thing because the transistor, the mute transistor, it's a PNP, and the way it's set up, let's see. Yeah, it's got a resistor giving the base a positive voltage, so it's biased off. Wait a minute. If that mute signal, wait. Where's it gone? Oh yeah, no, it's minus voltage. Okay, yeah. I was going to say, if that's a positive voltage, that transistor is definitely not coming on. It's in mute. No, it's not in mute. So there's your minus voltage. So that means that on R290, which is the base to emitter resistor, so on the base junction of R290 and Q110, we should see 15 volts minus a bit of volt drop because it goes through 2K2 resistor into two separate transistors. So whatever current the transistors are sinking through their base junction and the volt drop on a 2K2 resistor, but we will see voltage at the base of Q110 if it's out of mute. Two resistors. Okay. So the base is this pin here. Yeah, and that's exactly what it's supposed to be if it's out of mute, and I can explain why. If we look at this one, it's not too clear why it should be 3.9 volts, but if we scroll down to the other one that's in parallel with, there's a 3.9 volt Zener diode there. So that 15 volts, like I said, comes in 15, goes through 2.2K, 3.99. So at this node here, there's only 3.99 volts minus in reference to this rail. Alright, so it's not in mute. We can now definitely rule that out because yesterday when I checked that, in all honesty, I only checked it against ground. I wasn't actually thinking about the fact that I'd moved back into the stage that's referenced to different points. So, alright, now I'm happy that it's not in mute and that there's current going to that first diff pair. Now I want to calculate, well, let's have a look on the base of Q112 and the base of Q116, because whatever's on the bases of those gets mirrored onto the second diff pair, and whatever gets mirrored onto the second diff pair is your amp signal, bias currents, you know, what else? You've got your max power adjust, and obviously it's also going to have effect on linearity, like offset voltage. So the most annoying thing is that I don't know what voltage is supposed to be on the emitters of the the collectors of the long tail pair, the second pair. Like, I don't know, is it supposed to be, say, one's got the positive bias voltage of 3 times VBE Darlington output, like what, 7, 1.4, 2 point, like, you know, 3 volts on it, and the other one's got minus 3 volts on it. I don't know, because there's no voltages on here, so I just got to sort of work it out myself, which, yeah, it is what it is. So Q112 and Q116. And let's move this board up just a little bit more for you guys. Q112, Q116. Okay, that's these two here. I know I've already looked at these, but like I said, we're in reference to a different rail now. I'm looking from the top half, the plus 15. Actually, yeah, no, that's what I want to be looking at for now. Now I need to find their bases. Their bases both have decoupling capacitors, and one's got a 560 ohm resistor, the other's got a 22k, so I should be able to find it. Yeah, the way this board's laid out, it's just so annoying. Okay. That base has got minus 393. That one's got minus 6.5. So that's again where that 6 volts is coming from that we're still seeing getting transferred over to the next. Stage. Okay, interesting. Well, that goes back. God. You know, right at the start of the video, I remember saying clearly, I wouldn't be surprised if this is something right at the input stage. And, you know, because of the way amplifiers work, you know, you put something here, it's going to get fed through all the way to the output, get detected as DC and put it in to protect, even though most of the amplifier's fine. It's starting to look like that's what it was. The entire time I was going back slowly, testing transistors and isolating stuff, because I thought there was going to be a leaky transistor in here somewhere. No. God, who's calling me at this time of night? Just give me a minute, I've got to take a phone call. They hung up. Oh well, that's their fault. See, one side of it's got feedback, which concerns me because, well, hold up, where's that coming from? Yeah, that's feedback. That's coming directly off the output. That's what I thought. The thing that concerns me there is whatever DC offsets on the output's going to be coming back through feedback into the base of that. So if there is a problem somewhere in the output that I've overlooked,
You get what I'm saying? Well, DC can't flow through a cap. I don't want to take negative feedback path out whilst it's turned on, but that's the problem. Because with the way things are, taking that out could completely obliterate the output stage. That could be the only thing that's keeping it pulled down on one side, stopping both sides from passing current into each other. I haven't yet identified the faults, so I don't want to. I'm not taking nothing out unless I'm 100% certain that that can't happen. Not gonna lie, this has got me a little bit confused. One thing I can tell you guys, this PA88/86 that you see in certain boxes, all that is PA86 is the 300 watt version, PA88 is the 500 watt version, the one I've got. So as you can see, only the PA88's got that comparator IC in it, but they both have this. There's just different resistor values, which it's for the bias, and those values are noted down here, as you can see. So that's all that is, if anyone's wondering. So don't think I'm missing something. I really need to try and wrap my brain around this. Well, for starters, why is there only 0.3 of a volt here? Is my first question. Oh wait, is that supposed to be ground? Is that the grounded side? Ah, signal ground. There we go. Okay, so that's right. Looks like we're using what, JFET inputs on an op amp. Okay. You do you. Not my preferred way of doing it. This PA gear too, you'd think that'd be just too sensitive of a device for an input device. Oh, anyways, so that should be low. So where's the 6 volts coming from on the base of here? It can't be coming from here because this is capacitively coupled, right? So no matter what's on this line, even if signal ground wasn't at ground, so it's either coming out the op amp or it's coming from the feedback path. Let's look at R141 and R140 in reference to the 15 volt rail. R14140. Actually, that's probably going to be up here somewhere. Yeah. R144. No. Come on. Might have to pause the video again. Yeah, I'll pause the video whilst I find this. Sorry. Something just came to mind that I wanted to mention too, other than the fact that I'm trying to improve the whole setup here for you guys. I've noticed that the camera on my phone does this thing where I can tell what it is. It's the light sensitivity sensor. And if I move like this, oh, it's not doing it. Yeah, do you see that? The image jumping in and out? I notice it does that really bad in some videos. And I know, like, if I tap on the screen, it's supposed to lock onto a spot, but it doesn't stop that from happening. Now, I know this is probably a silly question, but is there a workaround for this? Like, do I just need bright lighting or something? Is there a setting on the camera that I'm not aware of? Is there a way I can lock it so it doesn't do that and it just stays where I put it? I
I tap. Oh, if I double tap it, it locks. You know what? I just answered my own question. I wish I could screenshot it and somehow put it in the video, but I, if I tap the screen once, this symbol of a lock comes up with a brightness slider on it, and I get how that works, but I thought that locked it, and it wasn't locking it. It turns out I have to tap it twice, and then it actually locks it, so... Alright, never mind, that's that problem sorted too. You can tell I've never done video editing or anything like that before, eh? Alright, back to finding these resistors. Alright, I found them. It's these two guys here. So those are so them two and that and those two are the negative feedback network. That's the 22 pico cap, and these are the 11k resistors. So, do I have... Yes, I do. Oh, that's right, because when the low voltage is powered, it is on the output, isn't it? Hold on. If I look... I think I've just answered my own question. If I look between ground and the output, yeah, 6, 7, 8 point... That would be 3 VBE drops away from 6 volts. That makes perfect sense. That's 6 volts coming through the triple Darlington. Oh no, wait. What am I saying? It would be lower, not fucking higher. God, I'm an idiot sometimes. So it's not... Let's just look on the other side of the resistor. 13. Huh. Hold on a minute. 17.43. 8.76. How's that physically possible if one end of those resistors... Oh, I must be on the second resistor. Okay. Dumbass Dave moment. Yeah, there it is. 8.75. Okay. So, we've actually got a higher voltage. Yeah. On... Yeah, the other end of the negative feedback circuit. So I don't believe that the output is got a problem in it and it's putting a positive voltage back through the negative feedback network, because the voltage is higher on the other side of the negative feedback than what it is on the output side. So that further confirms my suspicion. I mean, the fact that there's no bias kind of says it all. It's obviously in that section or before it, but yeah, I'm still baffled, I'm not going to lie. If I was to claim that I know what's going on at this point in time, other than what we've already diagnosed, I'd just be plain out lying. Okay, so, alright, let me just pause the video and think about what I'm going to look at next. Alright, well, I was just going to say I'll have a look at the output of the op amp, because it goes into that same base as the negative feedback on the diff pair, but it's capacitively coupled, so that's not where the whatever that voltage was. I've already forgotten. 17 volts or something stupid like that. Alright, more thinking, 1 minute. You know what? Something's not right. Right here with not this diff pair here. Sorry, Q1 12 and 116. These two here. Something doesn't add up here, because the only things that go to the base of the transistor... What's on its collector of Q116, which is the negative feedback side? Oh, sorry. What's on the base? That's that 6.91 volts. So that's the collector. Oh. But that just seems like the correct voltage that should be there. Okay, well, the only other point that connects back to something else, there's these two transistors at the bottom that are sort of arranged as the current mirror, I think. I'm a little bit confused. I'll just show you what I'm looking at.
Oh. Okay. I can't lock. Okay, I have to unlock it to do that. Alright, I'm learning. So there's like whatever that voltage was that we just tested there, which kind of makes sense because you got 3.3k, 6.8k, and then this goes down. There's only 2.2k at the bottom, so most of the voltage is going to be dropped across these transistors and these resistors, so I wouldn't expect too high of a voltage here at all, considering the top's only a 15 volt rail. That makes sense. So is my problem coming from down here? Like back from here? Let's look at this junction here. Let's look at R125. I want to see what's on R125. Can't work out if there's a voltage coming from somewhere that shouldn't be, or if we're missing a voltage, but why the diff pair is so far out like it is, leaving with no bias and everything. R125. Oh, that's right here. R125 is a 470k. That seems right too, because those two transistors are hooked up back to the end of R125, so you would see yeah, that seems right too. There's something I'm missing here. Ah, God. I think this video is getting a bit too long. I think what I'll do, because I've still got time to work on this tonight, I think I'll leave this here, where it is, upload this video and keep working. I'll make it a two-part thing, just so it doesn't end up being too longer of a video for you guys to watch. Alright, well, I'll leave this off here. We know where we're up to for the next one. Trying to work out what's going on with these diff pairs, why it's the first stage one's got nothing on one side and an erroneous voltage on the other side, and then the second pair's got full rail voltage on one side and 6 volts on the other. Just, yeah, something's completely up there.
So that's where we're up to. Alright, I'll see you in the next one. Thanks for watching, and if you like my content, please like and subscribe. I am a new channel. I'm only 2.5, coming up 3 months now, I think. So any help is greatly appreciated. Alright, with that being said, I'll see you on the next one.